So here we are again with a bit more about KiCAD. So I've been designing a project which is just a simple amplifier. So I've done 2 videos already, one of which shows you how to draw a schematic. The next one shows you how to convert that schematic into a netlist and to bring it into the PCB program. Here I'm going to show how to arrange these various components, draw tracks between them, and also how to change one of the components. So what happened before is this component here, it's RV1, and I said that it should be just a simple resistor, but actually it should be a potentiometer. So what we're going to do is we're going to go back to the schematic here, and you can see the schematic, there are 1, 2, 3 pins on it, so it's never going to work with a 2-pin device. So what we're going to do is we're going to open up CV PCB, and we're going to change the module that's associated with that component. So here we see I've said R1 and R2 are large pad resistors, but RV1 we don't want to be that, we want it to be a potentiometer. So I've just opened there to view the specified footprint, and I'm going to go through, and I'm pretty sure I already had a pot. Is it pot? Oops. There is a potentiometer, but that is surface mount. It might also be called variable resistor. So just been looking through here, and I've managed to find the various variable resistors potentiometers, and I'd actually designed one which has 2 sets of potentiometer size holes. So I'm going to go to my RV1 and I'm going to use RV various. Okay, so I'm now saving that, and that saves it to link the schematic and the netlist to the PCB file. So I've now saved it, and what I can now do is go back to the PCB editor, PCB new, and then I reread the netlist. But what I want to do is, I've changed one of the modules, so I want it to change the module. So I don't keep the module, I change it. And I read the same thing again, and now if you saw, this changed. There's no errors, there's no pads not used. And now if we look here, we have a look around, that is actually now all linked up with 1, 2 and 3 all linked up. So now we've got all the components as they should be. What I can do now is I generally, here I'm starting with the size of the PCB, so I'm trying to fit everything within this PCB, and there's actually not much to fit there, so it should be okay. This part of creating a PCB is very much spatial awareness and kind of art. There's no hard and fast rules. Generally what I do is I put the main IC, the main component with the majority of connections within the board, generally in the middle. So I'm going to do that here. So I'm going to move this main component, zoom in. So move things by pressing M. It's good to have a mouse and a keypad. Rotate things by pressing R, and I'm actually going to just put it right in the middle like that. So I'm just going to save that. It's also good to refer to the schematic that you've made, because this helps you figure out exactly what should go near to everything. So I know here that pins 1 and 8 are connected through R1 and C3. So if I get R1, oh, not the actual, and C3, I know that they will fit kind of like that. I keep a grid when I'm putting things down. I keep a grid of 25 mils, so that's thousandths of an inch. That allows you to align things relatively nicely. So we can align that so that the path between those two will be a straight line. And that's what I do for the components. When I'm then putting down the PCB tracks, I set the grid to 5, but I'll show you that in a second. So I'm going to just spend a bit of time putting all these, not put any PCB tracks between anything, but fit everything onto this board, and we'll see where we go from there. Just going to pause it now and I'll come back in a second. So now I have the various components arranged kind of how I want them. We might have to fiddle around with this a bit more, but I've tried to reduce the distance between these various connections and kind of follow how I think it should look. What I then generally do is I add tracks between everything. And generally you do you click on add tracks and wires, and if you you can see up here that we're on B.cu, which means bottom copper. So that's the copper that's on the bottom side of the PCB, and that is in green. If you want to change, then you can go to front copper, which is on the front, and you can see some of the pads are just in front copper and some are in both, so these kind of brown ones are in both front and back. So let's just use, I generally start with trying to do everything as bottom copper to start with, and then any additional bits I do as top copper. That's for a through-hole circuit. If it was a surface mount circuit, I would be using top copper as much as I can. So I can check here the design rules. This is how I change the track width. So there are two things here. One of which is the clearance, which is the distance between each track and between the different parts, and the other is the track width. Generally I try and use relatively large tracks, so I actually use 0.02 inches, and the clearance actually, let's leave it as 0.01. Maybe that we change that, and if it's a complicated board you can use a little bit less. So I'm going to click OK, and now I've clicked on add tracks and wires. I'm on bottom copper. When I click on one bit, I can then, it gives me this green line which I can move anywhere, and you can see it cleverly does a 45-degree angle mitered circuit track, and I'm trying to get, it highlights everywhere you're trying to get to, so I'm trying to get to this ground, this ground, this ground, this ground, this ground, this ground, this ground. Now it's, you can't connect, you can't go through one of these, so let's just try putting it down. So if I click there, it will hold there, and from that, click there, it will hold there from there, and hold that point and move around. So I'm going to just try, and I'm actually going to connect to this one here, and you can see now there's no white line because it knows that it's connected through there. And I'm also going to connect this ground directly to that one, and now there's no line between those because it's connected. I also want to connect to this, no, to this one. These are all connected through, so I'm going to connect from here and from this one through to there. So that's leaving us still, actually I'm going to delete this track because I want to move that resistor and this capacitor a little bit further apart because they're too close here. So if you want to delete a track, you can press delete on the keyboard and it will delete the track, or you can right click and you can do delete, and you can do delete track, delete segment. I wouldn't do delete net, delete track. So now, and I use escape to get off of the I was in tracks and wires mode. If you want to remove any of those modes, press escape. So I'm now going to just move that footprint. It's going to hit both of those. I'm going to move that. I'm going to move this a little bit forward. So there's a little bit of jiggling always. Yeah, I'm happy with that. So that's a bit better. So now it will remember the settings we put. So I can now put that path, that track back in. There we go. So we're starting to connect up a lot of this. Let's try and connect all we can as bottom copper. That's the output. I don't think we can do that. Is on top copper. This one we can do, and we can do to there. That is connected to that. So now I think we've done everything we can apart from this link here. We could do a convoluted route around here, but I don't really like that. That's a waste. So I'm going to delete that, and I'm going to change to front copper. Now I'm going to do the front copper connections. These can obviously go over the bottom copper connections because they're on different sides of the board, but they can't go through one of these holes, through holes, because that's on both sides. I did say I changed the grid to 5. I'm probably not going to for a simple board like this, but if you want much finer detail, change the grid to 5, and you can get these wires wiggling around a little bit better. So I'm going to zoom in a bit here, and I'm going to go from 8 to this capacitor. I'm also going to connect from on top copper with power, and also we're going to do ground, which actually goes around there. I'm also going to do this connection and this connection. So we're nearly there. This one needs to connect to, this might be a bit of a hassle. What I'm going to do, I'm going to connect from VBAT to there with the bottom copper. So I'm going to go bottom copper, VBAT to there, and now I can change to front copper, and if I'm lucky, you see I can't actually wiggle through there, it'll give me an error in the bottom left hand corner when I tried to go through this pad. See, if you look closely, the outer red line is touching the pad. When I click it, I get an error, and it means it won't allow me to do that. Now, maybe I can go through here. This is probably better. Yeah, that's much better. So let's go through there, connect that. So now there's one more connection, ground. So I'm going to actually do that ground in bottom copper, and I'm going to go like this. There we go. Right. So there's my PCB. So that's the end of this video. I'm going to do one more video where I show you cleaning everything up and exporting the Gerbers for production, and also doing some copper fills and things like that, and adding a bit of text.